How are you? This is Teacher Caren and you are watching DepEd MP TV. Today, we will be talking about fundamental counting principle. So, what are you waiting for? Bring out your paper, ball pen, and self-learning module and let's start. This module is intended for you to learn probability experiment and sample space, specifically to assist and provide you a general background in understanding fundamental counting principle. Here is the objective of the lesson. First, illustrate an experiment, outcome, sample space, and event. Second, count the number of occurrences of an outcome in an experiment using table, tree diagram, systematic listing, and fundamental counting principle. Before we start, let us check your prior knowledge about the lesson by answering the pre-assessment. Direction: read and analyze each question, then write the corresponding letter of your answer. For items 1 to 3, use the choices below. A. Sample space. B. Experiment. C. Outcome. D. Event. 1. It is any activity with an observable result. Number 2. The set of all possible outcomes or sample points of an experiment. Three. A particular result of an experiment. Four. It is a mathematical rule that allows you to find the number of ways that a combination of events can occur. A. Probability. B. Listing. C. Experiment. D. Fundamental counting principle. 5. Which of the following is an outcome when flipping a coin? A. Head. B. Tail. C. Head or tail. D. Not head nor tail. 6. What is the sample space when a dice is rolled? A. 6. B. 1, 2, 3, 4, 5, 6. C. Dice is rolled. D. Cannot be determined. 7. How many outfits are possible with 5 pair of pants, 2 pairs of rubber shoes, and 8 t-shirts? A. 10. B. 15. C. 40. D. 80. 8. For items 8 to 9, use the situation below. You have a choice of 1 vegetable, 1 fruit, and 1 meat in a community pantry. The vegetable choices are sayote, repolyo, lettuce, beans, and potatoes. The fruit choices are banana, papaya, and mango. The meat choices are pork and beef. Question number 8. How many outcomes show sayote? A. 4. B. 6. C. 8. D. 10. 9. How many outcomes show pork? A. 5. B. 10. C. 15. D. 20. 10. The digits 1, 2, 3, and 4 are written on small slips of paper. 2 slips are picked at random, one after the other. What is the sample space if the second slip is picked without replacing the first slip that was taken? A. 12, 13, 14, 21, 23, 24, 31, 32, 34, 41, 42, 43. B. 11, 12, 13, 14, 21, 22, 23, 24, 31, 32, 33, 34, 41, 42, 43, 44. C. 11, 13, 21, 23, 31, 33, 41, 44. And D. 12, 14, 22, 24, 32, 34, 42, 44. And this is the answers. Number 1, B. Number 2, A. Number 3, C. Number 4, D. Number 5, C. Number 6, B. Number 7, D. Number 8, B. Number 9, C. And number 10, A.
Many things in life are uncertain. Here are some. Will I get 95% in my math test? Will I not get sick this year? Will somebody greet me good afternoon today? These questions can be answered with words such as maybe, likely, or probably. People use their personal experiences and intuition to answer questions about an event's chance of occurring. But in the same case, it is possible to give a more precise numerical measure of chance. This is known as probability.
Probability is the branch of mathematics concerned with analyzing the chance that a particular event will occur. Its purpose is to attempt to predict the likelihood that something will or will not happen. Consider the following situation. Tell whether each event is certain, impossible, or possible. 1. My brother's team will win the basketball game. 2. Candy is sweet. 3. You will go sunbathing tonight. Let's check your answers. 1. Possible. 2. Certain. 3. Impossible.
In this activity, you are required to use a coin. Do you have it? Bring out 2 coins for you to use in this activity.
You may pause this video and resume after answering. For activity 1, in each situation, answer the following questions. Letter A, flip 2 coins together and observe the possible outcomes. 1. List all the possible outcomes. 2. How many outcomes are possible? This is the answer. For number 1, we have the outcomes are head-head, head-tail, tail-head, and tail, tail. Number 2, we have here 4 possible outcomes. Letter B, use the illustration below to answer the following questions. 1. How many shirts are there? 2. How many pairs of short pants are there? 3. How many pairs of long pants are there? And 4. How many possible outfits could you choose from? How did you arrive at your answer? The answers are, for number 1, 2, number 2, 2, number 3, 2, and number 4, 8.
Are you still there? Are all your answers correct? If no, try to understand each situation again. If yes, you may proceed to the next part of the module. In this lesson, you will learn how to illustrate and identify an experiment, outcome, sample space, and event. In addition, you will also learn how to count the number of occurrences of an outcome in an experiment using the following methods: the tree diagram and the fundamental counting principle. For lesson 1, we have experiment, sample space, outcome, and event. An activity such as tossing a coin, which generates data, is called probability experiment or experiment. A repetition of an experiment is called a trial. In the previous activity, flipping of 2 coins can have many trials, but results can be repetitive. If the results are recorded, there are only 4 possible outcomes, which are head-head, head-tail, tail-head, and tail-tail. To further understand probability experiment, let's consider the following definitions.
First, we have experiment. It is an activity which generates data based from measurement or observation. It is a chance process that leads to a well-defined result. Second, outcome. It is the result of a single trial of an experiment. And third, sample space. It is a set of all the possible outcomes of an experiment. Sample space is usually denoted by S and the total number of possible outcomes by N of S. And lastly, event. Event is the subset of a sample space that is a particular interest to the experiment. It is denoted by N of E. We have here example 1. The experiment is rolling a die. The possible outcomes are 1, 2, 3, 4, 5, and 6. The sample space is S is equal to, the elements are 1, 2, 3, 4, 5, and 6. The event is the even numbers, where N of E is equal to, the elements are 2, 4, and 6. Example 2. For each experiment, write the sample space and the total number of possible outcomes. For letter A, flipping 2 coins simultaneously. For letter B, spinning the wheel shown, assuming that the arrow will never fall in the line separating the 8 sectors. For letter C, rolling a coin and a die simultaneously. We have here the solution. For letter A, S is equal to, the possible outcomes are head-head, head-tail, tail-head, and tail-tail. So, N of S is equal to 4. For letter B, S is equal to, the possible outcomes are 1, 2, 3, 4, 5, 6, 7, and 8. So, N of S is equal to 8. For letter C, S is equal to, the possible outcomes are head 1, head 2, head 3, head 4, head 5, head 6, tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. So, N of S is equal to 12. Example 3. Suppose you draw one card at random from a standard deck of 52 playing cards. Find the following events. Letter A, a king. Solution. There are 4 kings, namely King of Heart, King of Diamond, King of Club, and King of Spade. Thus, N of E is equal to 4. Letter B. Find the following events. A club. Solution. There are 13 club suits. Thus, N of E is equal to 13. Letter C. Find the following events. A jack or an ace. Solution. There are 4 jacks or 4 aces. Thus, N of E is equal to 4 plus 4 is equal to 8.
For lesson 2, we have the fundamental counting principle. In an experiment, we can simply list and count the number of possible outcomes, or the sample space. However, there are cases that we find difficulties. Sometimes, we add them. Sometimes, we multiply them. And often, it is hard to figure out what to do. The fundamental counting principle in an experiment can easily be done using the following: A. Tree diagram, and B. Multiplication rule. Let us look at the following examples.
Under lesson 2, we have here the 2 methods. First is counting by tree diagram. Example 4. 3 coins are tossed. How many outcomes are possible? So we have here the solution. The first coin, the second coin, and the third coin. The outcomes are: the first is head, head, head. Second is head, head, tail. Third is head, tail, head. Fourth is head, tail, tail. Fifth is tail, head, head. Sixth is tail, head, tail. Seventh is tail, tail, head. And eighth is tail, tail, tail. Thus, there are 8 possible outcomes, or N of S is equal to 8. Example 5. How many tree-linked food chain are possible using the information below? We have here the producers, the primary consumers, and then the secondary consumers. Under the producers, we have corn and grass. Under the primary consumers, we have here rat and rabbit. Under the secondary consumers, we have python, eagle, and owl. Solution. We have here the tree diagram. Thus, there are 12 possible outcomes, or N of S is equal to 12.
The fundamental counting principle using the tree diagram is not always a practical method when it involves many and large number of choices. It would be too complicated to be presented in a diagram. Thus, let us look at the rule that is the most practical method to use.
Second method is by counting by multiplication rule. And the rule states that if one thing can occur in M ways, and a second thing can occur in N ways, and a third thing can occur in P ways, and so on, then the sequence of things can occur in M times N times P and so on ways. Example 6. A Toro Toro restaurant offers a special meal with a choice of 1 sandwich, 1 side dish, 1 dessert, and 1 drink. The following are the available choices. For sandwich, we have peanut butter, chicken, veggie burger, or fish fillet. For side, we have regular fries, cheese fries, or potato chips. For dessert, we have cupcake or apple pie. For drink, we have coffee, mango shake, Coke, juice, or Sprite. Solution. Basically, we just use the rule below. Multiply the number of sandwich, number of side choices, number of dessert choices, and number of drink choices. So letter A, we have 4 times 3 times 2 times 5 equals 120. For letter B, we have 1 times 3 times 2 times 5 equals 30. And letter C, we have, for show coffee, we have 24. For show shake, we have 24. For show coffee or mango shake, we have 48. And for letter D, we have 20.
To continue with the activity, bring out 4 coins, deck of cards, and 2 dice. You will be needing this to answer the activity. You may pause the video and resume after answering.
For activity 2, you may pause the video again and resume after answering. So in each experiment, count the total number of outcomes in the sample space. 1. 4 coins are tossed. 2. Drawing a card at random from a deck of identical card suits labeled 2 to 9. 3. 2 coins are tossed and a die is rolled. 4. 2 dice are rolled simultaneously, and complete the table below as your guide. So we have here the table, and we have here the answers. For number 1, the total number of possible outcomes is 16. For number 2, 8. Number 3, 24. And number 4, 36.
How was the activity? Were you able to get the correct answers? Yes, as long as you do it with focus. Let's sum up your understanding with this lesson by answering what I have learned.
For activity 3, choose the letter that corresponds to your answer below. Letter A, sample space. B, outcome. C, event. D, experiment. For number 1, 2 coins are flipped, then 2 dice are rolled. Number 2, S is equal to right or wrong. Number 3, head shows when a single coin is flipped. 4, getting an odd number when a die is rolled. 5, queen of diamonds. 6, head or tail. 7, flipping a 10 peso coin 5 times. 8, number 7 appears when spinning a wheel. 9, one-digit number is equal to, the elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. And 10, drawing a card at random from a set of cards 1 to 10. And the answers are 1D, 2A, 3B, 4C, 5B, 6A, 7D, 8B, 9A, and 10D. For activity 4, you may pause this video and resume after answering. So answer each given problem. Number 1, a plate number is made up of 3 letters from the English alphabet followed by a 3-digit number. How many plate numbers are possible if A, the letters and digits can be repeated in the same plate number? B, the letters and digits cannot be repeated in the same. For activity 4, you may pause this video and resume after answering the given problem. 1. A plate number is made up of 3 letters from the English alphabet followed by a 3-digit number. How many plate numbers are possible if A, the letters and digits can be repeated in the same plate number? B, the letters and digits cannot be repeated in the same plate number. Number 2, you have a choice of 1 main dish, 1 vegetable, and 1 beverage. The main dish choices are lobster, chicken, fish, or steak. The vegetable choices are ampalaya, lettuce, or broccoli. The beverage choices are soda, tea, or pineapple. A. How many outcomes show lobster? B. How many outcomes show chicken and broccoli? C. How many dinners are possible? And the answers are number 1, letter A, 17,576,000. B, 11,232,000. Number 2, letter A, 9. Letter B, 3. Letter C, 36.
Are you still there? Now, it's time for you to answer the post-assessment. Afterwards, check your answer honestly.
Direction. Read and analyze each question, then write the corresponding letter of your answer in your answer sheet. 1. Which statement is true? A. A true or false question has 1 possible outcome. B. Flipping a coin thrice has 3 possible outcomes. C. A true or false question has 2 possible outcomes. D. Flipping a coin thrice has 6 possible outcomes. 2. How many outfits are possible with 4 pairs of maong pants, 3 pairs of rubber shoes, and 6 t-shirts? A. 13. B. 36. C. 54. D. 72. 3. If 2 dice are rolled, which outcome has a sum greater than 10? A. 5 and 5. B. 4 and 5. C. 7 and 4. D. 6 and 5. 4. Given a sample space, the set of even numbers 10, 12, 14, 16, 18 is called blank. A. Event. B. Outcome. C. Experiment. D. Space. 5. Each question is answered with A, B, C, or D in a multiple choice test. If there are 3 questions, how many outcomes are possible? A. 2 times 2 times 2. B. 3 times 3 times 3 times 3. C. 4 times 3. D. 4 times 4 times 4. For items 6 to 8, you have a choice of 1 main dish, 1 vegetable, and 1 beverage. The main dish choices are lobster, chicken, fish, or steak. The vegetable choices are ampalaya, lettuce, or broccoli. The beverage choices are soda, tea, or pineapple. 6. How many outcomes show chicken? A. 2 times 3 times 3. B. 1 times 4 times 3. C. 3 times 3 times 3. D. 1 times 3 times 3. 7. How many outcomes show fish and lettuce? A. 3. B. 12. C. 18. D. 24. 8. How many outcomes show fish or steak? A. 12. B. 18. C. 24. D. 36. For items 9 to 10, 2 coins are flipped, then a die is rolled. 9. Which of the following is not an outcome? A. Head, tail, and 5. B. Head, head, and 1. C. Tail, head, and 4. D. Head, tail, and 7. 10. What is the total number of outcomes? A. 2 times 2 times 6. B. 2 times 6. C. 2 times 6 times 6. D. 6 times 2. For items 11 to 14, a commuter travels in 3 destinations. He travels first in bus or train, followed by van, jeep or minibus, and finally in tricycle, bike, or walking. 11. What is the probability experiment? A. The destinations of the commuter. B. The mode of transportations. C. Traveling in 3 destination route. D. Commuting in public vehicles. 12. Which is not a possible outcome? A. Bus, van, and bike. B. Train, jeep, and tricycle. C. Train, bus, and walking. D. Bus, minibus, and walking. 13. How many outcomes show bike? A. 6. B. 8. C. 10. D. 12. 14. In how many ways the commuter reaches his destination? A. 3 times 2 times 3. B. 2 times 3 times 3. C. 2 times 2 times 3. D. 2 times 3 times 2. 15. How many 4-digit numbers can be formed from the sets 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. If 0 cannot be the first digit and repetitions are not allowed. A. 10 times 9 times 8 times 7. B. 9 times 10 times 10 times 10. C. 9 times 9 times 8 times 7. D. 9 times 10 times 9 times 8. We have here the answers. 1. C. 2. D. 3. D. 4. A. 5. D. 6. D. 7. A. 8. B. 9. D. 10. A. 11. C. 12. C. 13. A. 14. B. And 15. C.
How was it? Were you able to get a passing score after checking your work? To apply what you have learned, do the additional activity in your module. You may pause this video and resume after answering.
For the additional activities, you may pause this video and resume after answering. Analyze the given situation and answer the given question. And we have here the situation. Mark Gideon has 4 different favorite types of milk tea. He loves winter melon, mocha, and buttermilk. He also loves 2 different flavors of ice cream scoop to be added, chocolate and vanilla. If Mark Gideon is given 3 sizes, which are small, medium, and large to choose, and together with the given flavors and ice cream scoop choices, how many different milk tea can he create? Your task is to solve this problem. You're going to present a tree diagram, then write the sample space and the total number of possible outcomes. We have here the answer. Your tree diagram may be presented in different ways, but the total number of outcomes is 18.
That was awesome, my dear learner. I salute you for accomplishing the activities and being with me in this session. I hope you learned something from our lesson today. If the topic is not clear to you, I suggest that you read your modules and watch this video again. So, goodbye for now, and this is Teacher Caren. We'll meet again soon in our next lesson.